Connexin, a subunit of Connexin, a protein that forms a gap junction, a channel that permits ions and small molecules to move between adjacent cells. The connexins are important to intercellular communication. Historically, gap junctions were first characterized by electron microscopy. They appeared to be specialized structures in the plasma membranes of cells in contact with one another. These specialized structures were then shown to consist of cell-to-cell channels. In analyzing the channels from different tissues, the components of these channels were found to differ. These components were named connexins. Mutations in the connexins are responsible for a diversity of diseases, including deafness and skin disorders. At least 4 connexins are known to be expressed in the ear. In many populations, mutations of the connexins are the most frequent cause of autosomal recessive deafness. Connexin mutations are also responsible for several forms of inherited keratoderma, a skin disorder characterized by thickened, hyperkeratotic, skin on the palms and soles, as well as peripheral neuropathy and cataract formation. Mutations in 4 connexins have been demonstrated in epidermal disorders. In 3 of these connexins, certain mutations result also in sensorineural hearing loss, deafness. Mutation of connexin 43 is responsible for the oculodentodigital dysplasia, the OD syndrome. The nomenclature of the connexins is somewhat confusing. The connexins have been designated by their molecular mass. Another system of nomenclature divides gap junction proteins into 2 categories, alpha and beta, according to sequence similarities. For example, CX43 is designated alpha, 1 gap junction protein, GJA1, while CX32 and CX26 are called beta, 1, GJB1, and beta, 2, GJB2, gap junction proteins, respectively. This nomenclature emphasizes that CX32 and CX26 are more homologous to one another than either of them is to CX43.